Uh, Hi everyone, this is Kumaran. Now we are going to see about sixth dimensional arithmetic progression. Before getting into that, I give you a small introduction where the use cases will be applicable. As we know that viruses, RNA, DNA structures, RNA, that's like a scale of nanometer. I want to give you the overview of how the nanometer is. This multidimensional mathematical arithmetic progression will be applicable at smaller, even smaller scale. For example, 1 meter equal to 100 centimeters. So 1 meter equal to 1000 millimeter, and 1 millimeter equal to 1000 micrometer, and 1 micrometer equal to 1000 nanometers. So nano at the nano scale also it is very much applicable. They're using this multidimensional formula. The same same approach is applicable to the difference between the numbers is very smaller, even smaller scale. It should be up to the will be same. So as we know about in the previous time, I told about it is a four-dimensional hypercube. It is a four-dimensional hypercube. Inside that we have a three-dimensional cubes available. So this whole structure is included into one single fifth dimensional hypercube. Similarly, now sixth dimension is nothing but this is a single sixth dimension which contains inside a fifth dimension of components. So if you see here, this is a fifth dimensional one, and this is a fifth dimension two. Inside that, this is a fourth dimension. Inside that, the dot of yellow color is third dimension. So as I told about previously, the fifth dimension we verify the values are coming properly. So So I want to make it more generic formula now. So to make you understand very much clear on this, so I just copy this arithmetic progression what we are doing it here. So imagine that we have n number of dimensions. So AP of arithmetic progression for nth dimension, nth dimension possibility, which is uh, which is nothing but rho into column into phases into and third dimensional cube. There is a third dimensional cube, and another one is fourth dimensional cube. So the hypercube of fourth dimensional fourth dimension, and it can be continued as it is up to hypercube of n minus one n minus one dimension. Why? Because I take an example here in the fifth dimension. This will be more generic. This is all divided by 2 into first number plus last number. So there is a generic formula which I find it out in my previous things. So I have my website. So I have found this formula for hyperdimensional to geometric progression as well. It is like a multiplication series. This is like a addition series for arithmetic progression, and geometric progression is for multiplication. It's a bit of a weird one. So I mentioned like Mn. So arithmetic progression, bro. It's like I mentioned instead of phases, phase in is as a diagonal one, and T meant to be like tesseract is nothing but a fourth dimensional. So this is a formula like given that as scenario. So NP is nothing but number first and then number last. NF number is NF is first number and NL is the last number. That is a different way of showing the mechanism. So in the mathematical representation, how we can say it is like this. We can say it as suppose we have a nth dimension. So here n equal to 1 up to k is the dimension. So it will be like this. N is from the first dimension is nothing but first dimension is row, second dimension is column, and then third dimension is phases, and the fourth dimension is cube. So n into so n into n multiplication of up to k minus 1 1th dimension, k minus 1th dimension divided by whole divided by 2. So n is continuously calculated. N becomes 1. Suppose like if I have that uh, nth dimension like a cube, so AP of arithmetic progression of nth dimension equal to, here n is represented from 1 to k. So I need to give k will be like anything like infinite. So if I take an example AP of fifth dimension, so this is also into first number plus last number. So n from the first dimension to kth dimension. Here it's applicable k minus 1 hypercube. So there is n into up to this hypercubical value of hypercube of k minus 1th dimension. So if I take an example of fifth dimension, mm, fifth dimension, n is here. mm, if you recalculate, it will come up to hypercubical dimension for fourth dimension. So hq up to is up to hypercubical of k minus 1. Here n value is 1. Here n value is up to 5. I mean k value is up to 5. So I can mention it here in nth dimension or kth dimension. Nothing. The representation will differ. So q of hyperdimensional cube with the value of up to fourth dimension. So fourth dimension. So first dimension is row. So n equal to 1 means row is there and column is there, and phases is there, and cube is there. If there is a fourth dimension, means hypercubical dimension of third dimension, which is nothing but simple cube. So this is what the formula we are extended for fifth dimension. So into first number plus last number, first number plus last number. To provide a bracket for clear clear view thought clear view separation in the mathematical formula. This is AP for fifth dimension. Now coming into sixth dimension. Okay, as we know about that, this is a generic formula. So that is a mathematical representation for one AP of kth dimension. The summation formula of n from n equal to 1 to kth. So k n is here 1. So if we represented fifth dimension, so from the row to row, column, face, cube, and fourth dimensional hypercube. So if you apply instead of k to 5, replace this 5, and then n equal to 1. So n up to hypercubical of k minus 1th dimension. So so k